Let's understand about resolution of a vector in a plane. Till now we learned how to add and subtract vectors, and through which we got resultant vector. That is, we derived resultant vector from two vectors. Now, let's derive two vectors from a vector. Let this is a plane. Let a bar is a vector in this plane. Now we will derive two vectors from a bar. Let b bar and c bar are two non-zero vectors in the same plane. Now, move b bar such that tail of b bar coincide with tail of a bar without changing its angle. Let this be point P. Now, move C bar such that head of C bar coincide with head of A bar without changing its angle. Let this be point Q. Draw an extended line from head of B bar. Draw another extended line from tail of C bar. Observe, both these extended lines meet at a point. Let this point be S. Let M be a real number, such that M into B bar equals to P S. Here P S is a vector. Also, let N be a real number, such that N into C bar equals to Q S. Here Q S is also a vector. And P Q equals to A bar. Observe, P Q R is a triangle. Apply triangle law of vector addition to this triangle PQS. We have PQ equals to PS plus QS. On substitution, A bar equals to M into B bar plus N into C bar. Here, these two vectors are derived from A bar. And also we can say A bar is splitted into two vectors. The process of splitting a vector is called resolution of a vector. Let's understand about rectangular components of a vector in a plane. Till now we added or subtracted vectors without taking any coordinate system. If we take coordinate system as reference, we get accurate results. Let's see how to add vectors in coordinate system. This is point O. This is x-axis, and this is y-axis. Let I bar is unit vector along x-axis. Let j bar is unit vector along y-axis. This is a vector A bar. Theta is angle between A bar and x-axis. Now project a line from head of A bar to x-axis. It meets at point AX on x-axis. Now project a line from head of A bar to y-axis. It meets at point AY on y-axis. Here AX is called horizontal component of A bar, and AY is called vertical component of A bar. Observe, These projections are called components of vector A bar. Here, the components of vector are perpendicular to each other, so they are called rectangular components. Now, let's see the relationship between these components and A bar. Now, vector along x-axis to point AX is AX bar, where AX bar equals to AX into I bar. Similarly, vector along y-axis to point AY is AY bar, where AY bar equals to AY into J bar. Apply parallelogram law of vectors to this case. We get A bar equals to AX bar plus AY bar. On substitution, A bar equals to AX I bar plus AY J bar. This represents A bar divided into rectangular components in a plane. Now let's find direction angle theta of the vector A bar. Now observe, we have a right angled triangle. To find theta, apply definition of sine and cosine to this right angled triangle. We know sine theta equals to opposite side by hypotenuse, which is AY by A, and cos theta equals to adjacent side by hypotenuse, which is AX by A. Dividing sin theta by cos theta, we get tan theta equals to AY by AX. R theta equals to tan inverse of AY by AX. This is the angle of the vector. Now to calculate magnitude of A bar, recall hypotenuse equals to square root of adjacent side square plus opposite side square. On substitution we get magnitude of A bar, which is A, equals to square root of AX square plus AY square.